Hello everyone, welcome to my new video of addressing modes of SIC-XE. Addressing modes of SIC-XE has been already covered in my earlier video where I have given detailed explanation about SIC-XE architectural features. But still I am making another video here just because this addressing modes play a vital role in deciding the target address, and also while we are doing the object code conversion in our next module, this is very important. So I'm making time to make another video on addressing modes of SIC-XE. So I hope you remember SIC-XE supports 4 different types of instruction formats ranging between 1 byte to 4 byte, and here is the slide containing 4 different instruction formats supported by SIC-XE. Format 1 will contain only 8 bits of opcode. Format 2 will contain 8 bits of opcode along with 2 registers. If you remember, while giving the register names, I have specified a table which also contains number associated with each register. That number represented in 4 bits is shown here. So in format 2 we can specify 2 registers represented by their number. In format 3, it is 3 bytes long, means 24 bits, and the split is like this. First 6 bits are treated as opcode, next 6 bits are NIX BPE fields, which are very important in determining the addressing mode, and remaining 12 bits will be treated as the displacement. And in format 4, again we have 6 bits of opcode, NIX BPE bits, followed by 20-bit address. This is address in format 4, and this is displacement. Whenever we have displacement, there is a need for calculation of the target address. Whenever I have 20-bit address, that means I have the address directly of the operand that has to be operated by this opcode. And what is this E bit? That is very easy to understand. If E value is 0, that means we are having a format 3 instruction. E value is 1 means it is a format 4 instruction. Now coming to the very important concept of addressing mode. NIX, BP and E bits of format 3 and format 4 actually determine the addressing mode of an instruction. So here I have already made up a summary chart. Please pay attention here. Two bits N and I should be processed together. Similarly, B and P should be processed together. So when it comes to N and I, we can have 4 possibilities. N value can be 1, I value can be 0, in which case the addressing mode should be treated as indirect addressing mode. N for indirect and I for immediate. So we are enabling N bit, means this is indirect addressing. And the next case is N value is 0, I value is 1. That means this is immediate addressing mode. What happens when both N and I values are 0 or when N and I values are 1? That is considered as neither indirect addressing nor immediate addressing. To represent neither indirect nor immediate form of addressing in SIC programs, we will use N and I both values to be equal to 0. And to represent the same in SIC-XE, we will make both N and I value to be equal to 1. Coming to B and P bits, these two will determine whether it is relative addressing or not. If B is 1, P is 0, we call it as base relative. Base relative, B for base relative. Similarly, if B is 0, P is 1, that will be PC relative addressing, and there is no case where both equal to 0, both equal to 1. Such case doesn't exist in our program. If it is both 0, that indicates that this is not relative address, this is something else. Okay, then when x value is equal to 1, we call it as indexed addressing. Now one more thing we have to study in this slide, that is how to calculate the target address in each case. Okay, so whenever it is base relative addressing, the target address is computed as, target address in case of base relative will be contents of base register should be added with 12-bit displacement. Okay, similarly for PC relative addressing, target address will be equal to contents of program counter register added with the 12-bit displacement. And these two relative addressing can be combined with indexed addressing. So if it is combined with indexed addressing, then optionally we may have to add the index register contents as well. So if B is 0, P is 1, X is also 1, then add X along with this. Similarly, if B is 1, P is 0, X is 1, then add contents of index register while doing the computation for target address. Okay, now how to compute target address for immediate addressing? What do you mean by immediate addressing? Data is directly available in the instruction. It is not present in a memory location. That means you don't have to compute the address of the operand. Data is directly present in the instruction itself. So there is no need to compute target address in case of immediate addressing. And in case of indirect addressing, normally indirect addressing will be either base relative or program counter relative, and more on how to access the data of indirect addressing mode we will see in the coming slide, where I have solved a problem which will clarify how to access an element from the memory if the addressing mode identified is indirect addressing. So N is 1, I 0 indirect addressing, N 0, I 1 immediate addressing, B 1, P 0 base relative, B 0, P 1 PC relative. Relative addressing can be combined with indexed addressing. When it is combined with index addressing, we have to add the contents of X along with the B or PC along with the displacement while computing the target address. So that is all. Now we will take up few examples which will help us to understand the addressing mode and also the target address computation in each case. So as a first example, this is the object code given. Let me choose pen. Okay, this is the object code given, and normally object code will be represented in hexadecimal notation. Okay, this is a hexadecimal notation of some object code. So now we will convert this hexadecimal value into a binary value. If I have to convert this into binary value, it is pretty straightforward. For each bit in hexadecimal, there will be 4 equivalent bits in binary. So we have 0 here. That 0 will be 4 zeros in binary. Okay, next we have 3. What is 3 in binary? It is 0, 0, 1, 1, 1. Sorry, it is 0, 0, 1, 1. Next we have 2. What is 2? 0, 0, 1, 0. Next is 6. 6 is 0, 1, 1, 0. Next again we have 0. 0 is 4 zeros. We have one more 0 in hexadecimal, that will convert to 4 zeros in binary. How many bits are there? You can see there are total of 24 bits in binary. 24 bit means it is format 3. Format 3. Next job is we have to identify the we have to identify the addressing mode. How addressing mode is identified? It is based on this NIXBPE bits, right? So we will process N and I together, B and P together, and E0 indicates what? It is format 3. B0 P1 means what? This is PC relative. N and I both are equal to 1 means what? This is neither indirect nor immediate. Right? So now how to compute the target address? Target address will be, addressing mode is PC relative, right? How to compute the target address in case of PC relative? PC contents has to be added with 12-bit displacement, 12-bit displacement, and we are going to get the target address. So now where do I get this PC content? See, here is a memory map. We have taken this memory map as it is from the textbook. PC content they have given it is 003 followed by 3 zeros. Base register content they have given, index register content they have given, and inside the box it represents the values, and outside the box it is considered as address. So these are the addresses here, and this is the value at a corresponding address. Okay. Okay, now what is the contents of PC? PC is 3000. What is 12-bit displacement? Where can I get the 12-bit displacement? It is over here. 12 bits of displacement is here. How much it is? This is 6, this is 0, this is 0. Right? So 600 is the 12-bit displacement. So if we add it together, we will get 3600. So where can I find the operand for this instruction? I can find the operand at the address 3600. Do I have the address 3600? Yes, it is right here. What is the value present in 3600? It is 103000. This is the value at the address that we have computed. So what operation that we are trying to perform? The first 6 bits here represents, the first 6 bits here represents the opcode. So what is the opcode? All zeros. 000 000 is an opcode for LDA. Okay, it is an opcode for LDA. LDA means what? LDA means load accumulator. With what? With data found at address. What is the address? 3600. So accumulator is going to be loaded with the value 103000. This is the operation that we have performed. Understood? We'll take up one more example. So hexadecimal value given is 03C300. First we have to convert it into binary. How to convert it into binary? Every digit in hexadecimal will have 4 equivalent binary bits. So 0 will be 0000. Next is 3. 3 is 0011. Next we have C. C is 1100. Next we have 12-bit displacement. I will not split this 12-bit displacement. Anyway, I require it as hexadecimal itself while doing the computation. So I will keep this 300 as it is. This is my 12-bit displacement represented in hexadecimal. Now what is the next job? Which format is this? This is format 324 bits we are having, means it is format 3, right? Next job is we have to identify the addressing mode. How do we identify the addressing mode? Please note, we will process N and I together, B and P together. E is 0, so it is format 3. Next X is there. So now tell me, when N and I values are 1 and 1, what is the addressing mode? This is neither indirect nor immediate, right? X value is equal to 1 means which addressing mode? It is indexed addressing mode. Now B value is 1, P value is 0 means what? This is base relative addressing. This is base relative addressing. So now we will compute the target address. How to compute the target address? Base relative addressing means we have to choose base register contents that has to be added with 12-bit displacement. Also, it is indexed addressing mode, so we also have to add index register contents to it. What is base register content? They have given it as 6000 plus 12-bit displacement is 300 plus index register content is 90. So if we add this up, we will get 6390. Please note these are all the numbers represented in hexadecimal, not decimal. They are all hexadecimal values. So whatever data is required for this particular instruction, it is present at the address 6390. Address is 6390. What is the value present there? 00C303. What is the instruction? All 6 bits or 0 indicates it is the LDA instruction. So we are going to load the accumulator with the value present at the address 6390, which is 00C303. We'll take up the next example. I suggest you to pause the video here, try out this example on your own. So what is this? This is a hexadecimal object code. Convert it into binary. When you convert it into binary, this will be the value 0000. 2 is 0010, and again 2 we have 0010, and 12-bit displacement I will retain it in hexadecimal itself. Now I have to identify the opcode. All 60 means it is LDA instruction. N and I should be processed together. N is 1, I is 0. So this is indirect addressing. X is 0, so no indexed addressing. B and P should be processed together. P is 1 means this is PC relative. E is equal to 0, thus this is format 3. Now how to compute the target address? PC relative, how to compute the target address? PC contents has to be added with 12-bit displacement. PC is 3000, displacement is 030, target address is 3030. So target address is 3030. What is stored there? 3600. Is that the value loaded it to the accumulator? No, this is indirect form of addressing. This should be again treated as an address of the operand. This is address of the operand. What is address of the operand? It is 3600. What is stored in 3600? 103 followed by 3 number of zeros. That is the actual value loaded into the accumulator. Please understand, we have identified it as PC relative as well as indirect form of addressing. If it is PC relative, we know how to compute the target address, PC content plus 12-bit displacement. When we do that, we will get the one address. Go to that address, get the value from that address. Is that the actual value? No. Instead, it acts as an address of the operand. So now again this should be treated as an address. Go to that address, fetch the data from there. This is the data that we are going to require. This is the data operated on by this instruction. What is the instruction? Load accumulator. Load the accumulator with the value at the address 3600. One more example. Now again we have 010030 in hexadecimal. Convert it into binary. convert it into binary. When we convert it into binary, 0 is 4 zeros, 1 is 3 zeros followed by 1. Next we have 0 again, means 4 number of zeros, 12-bit displacement. I will keep it as it is, 0 3 0. Okay, now what is the format? This is format 3 because E is equal to 0. N and I process together means N is 0, I is 1. This is immediate addressing. X is 0, no indexing. B and P both are 0, that means it is not relative addressing. How to compute the target address? What is the addressing mode? Immediate addressing mode means what? Data is directly available in the instruction. It is not present in the memory. It is available directly in the instruction itself. Immediate addressing means constant value is appearing in the instruction. What is that constant value? Now this is not address. Instead it is the value 0 3 0. And what is the instruction? All 6 0 means LDA. That means load the accumulator with the value 030. That's it. Here is our next example. Convert this value to binary first. 0 0 0 0 0 and 0 0 0 0. 3 is 0 0 1 1. And remaining 12 bits I'll keep it as it is. It is 600. Let's keep it as it is, this displacement part. Now coming over here, this is the opcode for LDA. Next 2 bits says that this is neither indirect nor immediate, and both values 0 will appear in SIC. So what is the instruction format of SIC? If you remember, we have 24 bits instruction formats. All instructions in SIC are 24 bits, and the 24 bit split is something like this. We have 8 bit opcode, and there is 1 bit for determining the addressing mode. Only 2 addressing modes were there: direct addressing mode, indexed addressing mode, and remaining 15 bits should be treated as address, right? So when both N and I values are 0, this will be an SIC instruction, not an SIC XE instruction. So it is just sufficient to note the X value to determine the addressing mode. X0 is direct, X1 is indexed, right? So remaining bits, that means this BPE is not treated as flag bits. Instead, this whole should be treated as 15-bit address. 15-bit address, right? What is the address we are having? This is already, this 12 bits is 600. And from this BPE, it is also part of the address. 011 is nothing but 3600. So what is the target address? It is 3600. So what is the instruction? LDA. That means we are loading the accumulator with a value present at the address 3600, which is nothing but 103 followed by 3 zeros. Right? This is a special example. Please note, when both N and I values are 00, you need not treat BPE as the flag bits. Instead, they should be treated as part of the address, right? And this X bit alone will determine what is the addressing mode. So if this X bit is equal to 1, then what we have to do? Target address has to be added with the index register contents only when X is equal to 1. Okay, so let us take up the last example. It is 0310C303. Convert it into binary. Okay, 0 is 00000, 3 is 0011, and then we have 1 means 0001, and we have 20-bit address. I will keep it as it is. 20-bit address will be 0C303. So N and I both are 1. That means it is neither indirect nor immediate. X0, no indexing. BP0, no relative address. We don't have to compute any relative address. E is equal to 1, format 4. Obviously it is format 4. By looking at the opcode, by looking at this object code only, we can tell that this is format 4, right? So how to compute the target address now? This is not relative. This is neither indirect nor immediate. How to compute the target address? No need to compute the target address. 20-bit address is directly available in the instruction. So what is the address? C303 is the address. Go to the address C303. Fetch the data from there. Instruction is LDA again. So load the accumulator with the value present at C303, which is 3030. So these are few examples that should make clear addressing modes concept. Thank you.